So the next 6.1 video is about average value. And average value is basically the average integral. If you're thinking about this is having a value, this is having a value, this is having a value, this is having a value at all of these given points, the average of all of these integrals really gives you the average value of the function. So this is written as 1 over b minus a to b, f of x dx. So you're just integrating from a to b, and then you are dividing it from that bound to find the average integral value in that piece. So, for example, what is the average area of the circles whose radii vary from 0 to 1? Well, the area of all circles is pi r squared. So we want to know the average area with respect to its radius, since that's what we're looking, from 0 to 1. So that is going to be pi, because I don't need it in the integral, r squared from 0 to 1 dr. That comes out to be pi r cubed over 3 from 0 to 1, which is 1/3, times pi, or pi over 3. So that is the average area of the circles whose radii vary from 0 to 1. Now, why did we need this? Because we can't possibly add up all of the radii from 0 to 1 and then divide it by that number to find the average. This is like an infinite sum instead of doing 1 plus 2 plus 3 plus 4, like adding all those individual areas up. We're adding all the possibles, so that includes radii of 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, up through 0.05, 0.1, 0.15, 0.2, 0.25, then everything in between. We couldn't possibly add up all those areas and then divide by that number. So we do the infinite sum divided by the bounds, and that gives me that value. So I have another example. So a theorem from the book says by MBT, if f of x is continuous on a to b, then there has to be a c somewhere in between them, such that f of c is the average value. So basically they're saying, okay, you've got this function, you have an f of a, you have an f of b, there has to be a c somewhere in between them that is actually the mean value of these two parts. So let's say we have m as the average value on this function on the interval of 0 to 2. We need to find c such that the average value equals m. So basically we're looking for m. Okay? So that means I need to add a little piece to this that I didn't. That function should actually be 2x. Well, let me put that in there. So I'm going to call it 2x squared. That needs to be there. So we want to go ahead and realize that the integral for the average value, we want to find the average value from 0 to 2 of 2x squared dx and 1 over 2 minus 0 to get that average. So I'm going to bring the 2 out. Really what I'm dealing with is 2 over 2, which is just 1, x squared dx, which is x to the 3rd over 3 from 0 to 2, which is 8/3. So that's my mean value. We actually want to find c, though. Find c. I found m. So to find c, I need to know what x value actually equals 8/3. So multiply by 3 if you want. or divide by 2, you'll get 4/3. And x then equals the square root of 4, which is 2 over rad 3. And that's your C value where m occurs. So the mean value on 0 to 2 is 8/3. That's the mean value between A and B. That's the average value between 0 and 2. And that 8/3 occurs at 2 rad 3 equals x.